Hello, and a very warm welcome to everyone joining us for today's Select Science webinar. Earn your black belt with Nunchuck's LNP making skills. My name is Dora Wells, and I'll be moderating today's presentation. I'm delighted to be joined by today's speaker, Martha Perez, Marketing Director at Unchained Labs. After earning her PhD in biophysics from the University of Rochester Medical Center, Martha investigated vaccine development as an NIH Ruth L. Kirstein National Research Service Award postdoctoral fellow. Now has been working for Unchained Labs for over 7 years and is now marketing director and product manager for Nunchuck. After the presentations, we'll move on to our question and answer session. Please feel free to ask any questions for the Q&A session at any time during the webinar. You can submit your question at the speech bubble icon to the left of your screen. And now, without further delay, I'd like to hand over to Martha for today's presentation, and I'd like to thank her for presenting to us today. Please take it away.
Hi, I'm here to introduce you to Unchained Labs Nunchuck. After this session, you will have earned your black belt with Nunchuck's LNP making skills. As Napoleon Dynamite would say, researchers only want instruments with good skills. You know, Nunchuck skills, total flow rate screening skills, lipid nanoparticle formulation skills. So let's get to it. LNPs are incredibly diverse and versatile particles. They can be made for a variety of different targets and applications. In fact, LNPs are being developed to solve problems in such diverse fields as gene therapy, cancer treatment, and vaccine development. LNPs can do so many things because of the versatility of their two main parts, the payload and lipid layer. The lipid layer can consist of a variety of different lipids. Those lipids help to protect the vulnerable payload until it gets to its target, and then it releases the payload in the right place. The payload can be RNA, DNA, protein, or practically any other active pharmaceutical ingredient, some of which could be impossible to get to that target without the protection of the lipid layer. A third characteristic that is also really important is size. Size can determine which cell or organ that the payload will get to. We can see how useful LNPs are, so why aren't more therapeutics using them already? Well, part of the reason is that just like that cake that you try to copy from social media, they are harder to make than they look. Let's see how scientists are making LNPs now. Unfortunately, many scientists find that the current solutions fall short. They must deal with either kludgy homemade setups, lots of tubing that can get tangled and needs to be replaced, hard to use instruments that weren't designed for LNP making, or they have to buy one box to screen and make small volumes and another much more expensive box for larger volumes. We have the solution for these problems. Nunchuck is the first and only platform that combines two key steps needed to make a perfectly sized LNP: total flow rate screening and LNP formulation. With Nunchuck, you can make 50 to 200 nanometer size full LNPs. Screen 8 total flow rates, TFRs, in just 10 minutes using only one consumable. So you can tune in your perfectly sized LNP. Then jump straight into making a little or a lot. With Nunchuck, you can make from 0.5 to 200 milliliters of your LNPs. How do we do this? The Nun gets it done. Here on the left side, we are showing you the Nun as you would use it. You would never need to open it up, but we don't want this to be a black box, so we opened it up for you so that you can see what's inside. Let's take a closer look. Nunchuck is so easy to use. First, you will load your syringes with aqueous and organic solutions. Then you slide the nun into position on Nunchuck. And finally, you will lock your syringes into the nun consumable. Here is the aqueous inlet and organic inlet. As you can see, there's lure locks here where your syringes would lock into place. The nun contains the entire fluidic pathway. So there's no need for cleaning the instrument, and you never have to worry about cross-contamination. Plus, there's a little window under our patented microfluidic chip. That's for Nunchuck's camera, which automatically watches for the flow to start, so you can capture as many LNPs as possible. White belts are welcome to Nunchuck software. Nunchuck is so easy to use, even a newbie can kick it off in minutes. All of Unchained Labs software is application-based. That means that we design it with your needs in mind. First, choose what you want to do, either a screening run or a prep run. Then we gave you as much choice as possible to enter as little information to get up and running in less than 2 minutes. Or if you want to keep detailed information about your formulations, you can use our formulations manager to store as many formulations as you want. The last step is to choose your flow rate ratio. We can do from 1:1 to 10:1. Your desired sample volumes per TFR screened, when you're doing a TFR screen, of course, and your total flow rates. The Nun's novel microfluidic mixing chambers can handle flow rates from 0.5 to 30 milliliters per minute, which means that it can create a wide range of LNP sizes. As you can see, you'll be an LNP black belt in minutes. Now, before I show you some data generated with LNPs made on the Nunchuck, I must introduce you to Unchained Labs LNP tag team. In the next 3 slides, I will show you data for size and polydispersities of LNPs. That data all came from Stunner. Stunner is the only system that pulls together UV-Vis concentration, dynamic light scattering, DLS, and static light scattering, SLS, data from the same 2 microliter sample. We used Stunner to show that LNPs made on Nunchuck are high quality LNPs. Let's see data from 2 TFR screens. These data are from 2 different experiments. The one on the left-hand side shows data from LNPs made on Nunchuck that are using the lipid SM-102, and the payload was poly-ARNA. On the right-hand side, you see data from LNPs made on Nunchuck with SM-102, again, as an ionizable lipid, and mRNA as the payload. On the left-hand side of each graph, you see the green axis, which relates to the size of the particles made. The green bars represent the data from the size of each individual total flow rate tested. As you can see, as you increase the total flow rate, the size of the LNPs decrease, just as we expected. The right-hand axis in blue, that's the polydispersity index, PDI. As you can see, they are consistently either under 0.2 or 0.1. That means that the populations of particles are very homogeneous. That's what we want. We want high quality LNPs. So we would have a size target in mind for this particular project. And once we know what TFR makes the size LNP that I need, then I could simply level up to 200 milliliters. The first data bar here in this graph is the data from the screening run. And what I wanted you to show is that regardless of whether you're using the screening run or the prep run, you get the same size particles. The rest of the bars, 1 through 20, are batches of the same LNP that were made by adding more reagents to Nunchuck. By allowing you to add reagents to Nunchuck, you can keep making LNPs with the same nun. And we never saw a decrease in the quality of LNPs made up to 200 milliliters. We also tested different chemistries, and we were able to create high quality LNPs for them all. Here you can see DOTAP, which is a cationic lipid, and 2 ionizable lipids, all behaving the way you would expect. As you increase the TFR, the size of the LNP decreases. Do these LNPs have other properties that you would expect them to have? Well, yes, they do. We measured zeta potential for all 3 LNPs in 2 different buffers. A buffer of pH 5.2 in the yellow bars and another buffer in pH 7.4 in the purple bars. As we expect, since DOTAP is a cationic lipid, the LNPs made with this lipid, that zeta potential was not strongly impacted by the pH of the buffer. But both the ionizable lipids, which have a pKa of about 6.5, the LNPs made with ionizable lipids, their zeta potential is impacted by the pH of the buffer. So these LNPs behave exactly the way that we expect them to. Okay, now everyone here has their Nunchuck skills. You can all make 50 to 200 nanometer size full LNPs. Screen 8 TFRs in 10 minutes using just 1 nun. And then when you know which TFR makes the perfectly sized LNP, you can make a little or a lot from 0.5 to 200 milliliter LNP formulations. So remember, when someone asks you, what is a Nunchuck? You can say, not this guy, this one. Any questions?
Great. Thank you for that interesting seminar, Martha. Now let's move on to the Q&A session. Just a reminder to the audience to submit your questions, and you can do so by clicking the speech bubble icon to the left of your screen. And now the first question we have here is, what are the maximum and minimum volumes possible with Nunchuck?
Yes, good question. So the minimum volume that is available with the Nunchuck is 0.5 milliliters in our prep run, and you can make up to 200 milliliters using the same non-consumable. And the way that you do that is that the Nunchuck allows you to add more reagents to the instrument while you are creating these up to 200 milliliters in batches.
Great, excellent answer there. And the next question I've got for you, Martha, is how is encapsulation efficiency measured for the data presented?
Yeah, good question. I did not specifically state that. And when I was showing the data based on the stunner, that was the sizing and polydispersity data. And I referred to encapsulation efficiency, meaning that I gave data as to how much of that payload actually was inside of the LNPs. And that was done with a basic ribogreen assay, so not on the stunner. Whereas the stunner can give you the answer to how much of the RNA or DNA or protein is within the whole sample. It doesn't tell you the difference between what's inside and outside of the LNP. So we do have to use an assay for that off of the stunner.
Great, thanks for clarifying that one. And the next question I've got here is there any way with Nunchuck to keep a record of what formulations we have used? And if so, is the number limited?
Yeah, so with the Nunchuck, we have made it so that you can get up and running as fast as possible. And sometimes you just want to get to your preparation. And you don't want to sit there and type out the name of your formulation. So you can do that using a generic name, like just aqueous formulation or organic formulation. Or you can take down as many notes as you would like, because you want to keep like really detailed, accurate records, and you can do that. We don't have any limits for the number of formulations that you can enter into the formulations database, and you can easily search through the database using a keyword, and it'll bring that up real quickly. So super easy to use, flexible, as little or as much information as you want to enter into it.
Great, thanks a lot for that. And what are the minimum and maximum flow rates possible with Nunchuck?
So the minimum and maximum flow rates that are possible are from 0.5 milliliters per minute to 30 milliliters per minute. And what that means is that we have the possibility to make a really wide range of sizes of LNPs with the Nunchuck.
Fabulous, thank you for that one. And the next question from an attendee here is, can you save a template if you want to run the same settings over again? And how many templates can be stored?
Yes. So so this person's probably thinking that I find some instrument parameters that do exactly what I want them to do, and I want to keep running that same experiment over and over, and I don't want to keep on inputting it. And so we decided that you don't have to like click a template button, because when you're programming it in, you don't necessarily know that this is going to be the perfect settings that I want to go back to over and over. So every single run you can go back to the previous runs, and you can just use the parameters used previously to create a new run. And that is sort of quote unquote a template, but you can also like slightly tweak it so that if you want to start from somewhere, but you want to make a slight change. So you have those options, and there's no limits to what you would consider a template, because it's basically every single run that you've previously done on the Nunchuck.
That's great, thanks for that one. And the next question here is, how would I make larger LNPs with Nunchuck than what you've shown today?
Mm-hmm. Yeah, so the size of LNPs is dictated by a lot of different factors. And part of what goes into what size the LNP is going to end up is the chemistry of the lipids that you're using, the type and size of your payload, and then, of course, the instrument settings. And as I mentioned, we have a wide range of instrument settings so that to give you the ability to make a lot of different sizes. But once you make an LNP, that's only kind of like the beginning of the story for what size it's going to be. Other factors after making LNPs, like what kind of solution you let the LNP sit in, and for what amount of time. When I'm talking about a solution, I mean, for example, what's the percentage of ethanol in the solution? How long you let them sit in that solution before taking them out of that solution by dialyzing them in some way. All that is going to affect the size. So there's a various number of variables at play.
Great, thanks a lot for that. And the next question I've got here is, are there barcodes on your consumables?
Okay, no, they're not. So they're, there's nothing on the consumable that says, like you already used this before or anything like that. The box does come with lot numbers, so you can keep track of what lot numbers you've used. And so that makes it so that if I were a user, I could do a TFR screen. And if I wanted to use that TFR screen to select my optimized settings, and then quickly that same day wanted to make some preparation with the same chemistry. Now, I would never say you could do anything on the same nun with a different chemistry, but with the same chemistry, you could potentially turn around and do prep mode with something that you've done the TFR screening with. So that is very flexible. Again, we try to make our systems as flexible as possible for scientists.
Perfect, thanks for that. And we've got a lot of people coming in saying thank you for the interesting presentation. So that's great, thanks a lot for that. I'm glad that you've enjoyed it. And I've got an attendee, Martha, here, who's asking whether Nunchuck can be also used for making polymeric nanoparticles.
Okay, great question. So we do focus on LNPs because Unchained Labs is a biologics tools company. So we focus on the LNPs are what most people in the biologic space are using, but many people are also trying polymeric nanoparticles, and Nunchuck is completely agnostic to what chemistries you're putting on it. So it would be one of those things where you would just try it. I would just, since I don't know the details of your specific chemistry, I would just remind you that Nunchuck does not have a heating element. So if there's a heating, some polymers need to stay at some elevated temperature during formulations. That's not possible on Nunchuck, but it'd be one of those things where you could definitely try it once you get your Nunchuck.
Great, thanks a lot for that informative answer. And I think we have time for just one more question. And that question is, does the Nunchuck have the capability to calculate PDI and Z average?
Yeah, I'm glad you asked this question because I'd like to clarify that. The Nunchuck is an LNP maker. So that means that that's what it does. It does not have onboard analytics. And that's why I referred back to introducing the LNP tag team, where you make your LNPs on the Nunchuck. And immediately after making them, I'm going to want to analyze them to see what characteristics they have. And then I put them on the stunner. The stunner is our instrument for dynamic light scattering, DLS, which gives us the size and PDI of the LNPs.
Okay, great. Thanks for that one. And I'm afraid I'm going to have to wrap it up there. But thanks again to Martha for today's informative discussion and presentation. Thank you to everyone joining us online and for your interesting questions. I hope that you've all found this a worthwhile session. If you have any other questions, please feel free to email me at editor@selectscience.net, and I'll follow up with your questions for Martha. Remember, you can also download a certificate of attendance in the Related Resources tab to the left of your screen. And if you'd like to listen again to today's webinar or invite a friend to listen, it will be available to watch on demand in a few days. Goodbye, and thank you once again for joining us.